March 17th, Brian. Today's March 17th, and we're going to be going over log functions and their graphs, okay? There is a PowerPoint that I'm going to go over, and you're going to follow along with your notes. There was a handout that you picked up when you walked in. Whenever you see a blank, or when you see me write a red line underneath, that's going to be part of the blank. Okay. The first thing we're going to learn about today is log functions and their graphs. So we were studying exponential functions before. Now we're studying log functions. Oh, you can't see that. I'm sorry. I'm sorry. I was on the wrong page. Okay, so this is your PowerPoint. Okay, the first, do you have a question? Your goals for this topic, I guess, are going to be to recognize and evaluate log functions with base A. Okay, so what is a log function with base A, and how do you evaluate it? You actually learned a little bit about it during your warm-up. Okay, next thing, your other goal for this section is to learn how to graph log functions. You're going to learn how to recognize, evaluate, and graph natural logs. Okay, natural logs are very similar to log functions. They're like partners. And you're going to learn how to use log functions to model and solve real-life problems. Okay, there's a lot of real-world applications for the log functions, which I hope to explore with you guys later on in the week. If you go to the next slide, I want you to graph 3 to the power of x. So go ahead and graph that in your calculator. Okay, so back to where we left off. This is the graph of y equals 3 to the power of x. Is this function 1-to-1?
Yes.
How do you know?
It goes all the way up.
It goes all the way, yeah, because it said that on the board. How about we do this? All right, guys, so based on the conversation we just had, is this function 1-to-1?
Yes.
Yes, it is. Why? Good. Can you put that in the context of domain and range?
It's one element of the range.
One element of the range corresponds to one element in the domain. Okay, very good. This must pass the horizontal and vertical line test. You want to go ahead and write this down. So it has to pass both the horizontal and the vertical line test. If I run a pencil along, or my arm along this graph, does it pass the vertical line test? Yes, that one's easy to see that it does, right? Now, if I turn my arm down and do the horizontal line test, does it pass the horizontal line test? Even at this point right here? Yeah? Okay, why? It looks to me like it's pointing at more than one point. Why is it passing the horizontal line test? Okay. And why? Why is it only touching it once? That's what I want you to
Because
answer.
it's going like, it's kind of technically going down.
Good, it's decreasing. You can't really tell, like with our eyes we can't, but if we were able to zoom in, we'd be able to see that it's slowly but surely going down and down and down and down. Very slowly though.
So like, that's why when you have it straight, it's not, the line's not straight with the line. You know what I mean?
Right. The way that you could check your answer is by looking at the table. Okay, the table will show you that the y values are changing. Very good, Anthony. All right, so does it have an inverse?
Yes.
Yes, it has an inverse because it is 1-to-1, okay? And it passes the vertical and horizontal line test. All right, here's the definition of the log function of base A. It is very long, okay? I'm going to try to break it down into English. The exponent has to be greater than 0. The A value has to be greater than 0, or the base has to be greater than 0, and A cannot be equal to 1. If you have 1 to the power of 1, what do you get? What's 1 to the power of 1? 1. What's 1 to the power of 10? 1 to the power of 100? 1. Okay, so if A is equal to 1, you just get 1. You get a straight line at 1. And that's not an exponential or a log function. Okay, so those are your restrictions. There's this long little saying right here, if and only if. That's what you learned in the video, so I'm not going to go over it very much. The function log base A of x is called the logarithmic function of base A. So you read it as log base A of x. Okay, so log base A of x. Okay, can I move to the next slide? Okay. The most important thing to remember about logarithms is a logarithm is an exponent. What time is it exactly, Brian? Okay, so we got 3 minutes. A logarithm is an exponent. Okay, so what does that mean? If a log is an exponent, that means an exponent must be a log. Exactly. Smart.
Vice versa.
Okay, vice versa. Therefore, all logarithms can be written as exponential equations, and all exponential equations can be written as log equations. Okay, they go one forward and backwards. Okay, to wrap this up, we need to answer these last few questions.
Oh, you mean copy the answers?